Okay, so chapter 10, correlation and regression, section 10.1, correlation. Uh, this section is about finding the correlation between sets of data. For example, you have the sets of data, and we would like to find out what is the relation between them. How can we find the relation between them? Uh, that's correlation, and especially we use linear correlation. Whenever you look at the data, if you have the set of data, you can say that one is x values and another one is y values, and you can plot the set of data, and that gives you some kind of graph. And based on the graph, if the graph looks like linear, like a straight line, then that's called linear correlation. We can calculate how much they are correlated, okay, in this section by using some formula. So correlation exists between two variables when the values of one variable are somehow associated with the values of another one. What is that? Okay. So linear correlation means it's the relation is somehow linear, straight line. Some examples here. This is the we are plotting the data, x values and y values, and as you can see that when x is growing, the y is also growing. Somehow, it's uh, it's linear. As you can see that if I draw a line like this, it's linear, it's going up, so it's a positive correlation. Here these are the sets of the data, and as you can see that it's not on the one line, but the relation is a linear, it's going down. So the relation is it's a linear correlation, and we say that there is a negative linear correlation because the straight line is going down. Sometimes we might have data like this, which is not possible to, there is no way we can draw a line where most of the data is around that line. Sometimes when your x value is growing, the y value is going down. Sometimes when x value is going up, the y value is going up. So there is no straight line which can be used to represent this relation. So that is the correlation. Sometimes you might have a relation like this. This is they are somehow related, but it's not a linear relation. It's a non-linear relationship. Okay. Okay, so we can measure that correlation in this section, and we represent that, and the notation for that linear correlation is we denote it by r, and we try to find out the value of r, how much they are related. And when we solve the problem, you can read this objective and these notations you have available in this section in your book. These are the notation we're going to use, and I'm going to just go to the formula. This is the formula you can use for finding the relation, but you can also find the correlation by using your TI-8384 calculator. So today I'm going to go over one problem where I'm going to show you how to use a TI-8384 calculator. Okay, and one more thing which is very important while making some claim using the correlation and interpreting the data, when p-value is less or equal to alpha, which is significance level, uh, then if p-value is less or equal to alpha, that supports the claim of linear correlation. And if p-value is greater than alpha, that does not support the claim of the linear correlation. I'm going to show you by using the data how to find the value of r, how to find the p-value, and how to compare them. And then this is the most important uh, you know phase you have to understand. If the correlation, which is r, is greater or equal to critical value, there is a way to find out the critical value by using the table. I'm going to show you that as well. Then we can conclude that there is a sufficient evidence to support the claim of a linear correlation. If the absolute value of r is less than critical value, you have to make sure that this is the absolute value. Okay, that conclude there is not sufficient evidence to support the claim of a linear correlation. So this is the very important page you have to understand. And there is one more thing. Where is that? This is just some. Okay, this picture, is there a linear correlation? And if your critical value uh, critical value from table is 6, we can find the critical value, we can find the value of r. If r is from left side to the right side, this is from this critical value to that critical value, meaning from, let's say critical value is zero point 0.5, then that means from negative zero point 0.5 to positive zero point 0.5 there is no correlation. Anything after zero point 0.5 or before negative zero point 0.5 there is a correlation. So we are going to use this thing to find out the correlation. Okay. uh, so I'm going to show you one example where you can use calculator and make this conclusion. Okay, so basically I'm going to show you how to use calculator to calculate this correlation coefficient here. So let's look at one problem from section 10.1, and this is a problem, what is that, problem 6, right? So this is the data we have given. Refer to this picture here. We need to, there are 10 datas. We need to, so A, we need to examine the pattern of 10 points and subjectively determine whether there appears to be a strong correlation between x and y. So if you look at this data, as you can see here, when x is 1, the y is 1, 2 and 3. When x is 2, there are 3 points, y value is 1, 2 and 3. When x is 3, the y value is 1, 2 and 3. And when x is 10, the y value is 10. So there are 10 data. So we're going to use this data and do the data points appear to have a strong linear correlation. If you look at this data, then as you can see that if you try to draw a straight line, as you can see that as x is growing, the y is growing as well. So somehow it is correlated, linear correlated. I can't draw a line here, but I can show you. Even your data look like this, somehow if you draw a line here, most of the data are around this line. That's called linear correlation. So we can just roughly make conclusion that this data appears to have a strong linear correlation. Yes, the answer is yes, because they appear to be on not exactly on same line. You don't have to have on the same line, but if you draw a line like the way I draw here, most of the data they are around this line. So I can make this conclusion, yes. Okay, now the question is, how do you find the correlation coefficient using this 10 data? For that I'm going to use instead of using the formula, this formula, you can calculate that thing by using this formula, but I'm going to use a calculator. Okay, how to use calculator, TI 8384 calculator, to find out the correlation coefficient. First of all, you have to use this data. As you can see here, the data sets, when x is 1, y is 1, and there are 3 y value, 1, 2 and 3. So I'm going to put this data value here by going to stat, edit, and these are the place where I can put the x values and y value. When x is 1, the y is 1. When x is 2, there is x is 2, the y is 1 again. When x is 3, the y is 1. So for 1, 2 and 3x, there is 1 for each of them. Okay, similarly for when x is 2, when x is 1, the y is 2, 2, 2. So 2, 2, 2, 3 times. When x is 1, 2 and 3, again the y values are 3, 3, 3. So you can see that it's repeated. Finally, the last one is when x is 10, the y is 10. So I'm going to put when x is 10 in the list 1, that is x value. I enter that, and I go to the list 2, then y is 10. So these are the x values. The list 1, they represent the x values, and list 2 represent the corresponding y values. Okay, so these are the data we have. Now how to find this correlation coefficient? For that, go to stat here, go to test, and go down here until you find linear what is that, DF, linear regression test. That gives you the correlation coefficient and everything whatever you are looking for this problem. So enter here. So x value is coming from list 1, y value is coming from list 2, It's already there. The frequency means repetition, no repetition, so we always use frequency 1. And our claim is, they are correlated or not. So if they are not, then we just use this not equal to 0, meaning no correlation. And then we go down and calculate, hit the calculate button. By doing that, we find all the information. If y equal a plus bx is a straight line, we can draw here, we can find out the value of a and b, and this t is t statistics value, as you can see here. P is the p value, df is the degree of freedom, and a is this value of that straight line. If you try to draw a straight line, we can represent that straight line by using this formula y equal a plus bx, and that is the value of a. And if you go down, you can find the value of b and value of standard deviation, value of r square, value of r. This is what we are looking for here. R is the correlation coefficient, which is 0.905, rounded to the 3 decimal place, which is 0.906. So 0.906, that's the correlation coefficient. Excellent. If you keep continue, the next question is there a linear correlation between x and y using alpha equals 0.01? And here in this case, I want you to go to this place here. Is there a correlation between is there a correlation between x and y? For that, you have to find out the critical value. As you can see here, there is a correlation if the absolute value of r is greater or equal to critical value. So how do you find the critical value? We can use the table provided here for finding the critical value for this alpha and for this number of items. If you click here, it's going to give you the table for critical value for n equal, in this case, the number of the size of the data is 10. There are 10 data, so n equal 10. Alpha is 0.01, so 0.01 is this second column. So when n is 10, the second column, the critical value is 0.765. That's the critical value. Look at here. Compare this critical value 0.765 with this correlation coefficient, which is 0.906. Which one is greater? This one is greater. Definitely it is 0.9 and it's 0.7. So we can use this conclusion because the correlation coefficient is greater than the critical value. The conclusion is there is a sufficient evidence to support the claim of a linear correlation. So we can choose that option here. Yes, because the correlation coefficient, is there a linear correlation between x and y? The answer is yes. Because the correlation coefficient is not in the critical region. No. Yes, because the correlation coefficient is in the critical region. So this is the answer we're going to choose. Okay, because the the correlation coefficient is greater than the critical value we got from the table. Make sense? Okay, next, what is the correlation coefficient when the point 1010 is excluded? So from this data, we would like to find out the correlation coefficient. Very same thing by excluding 1010. So we have to go back to this data set as we enter here, and we don't want the last point, this 1010. So I'm going to delete this, and I'm going to delete the x values and y values both. Now the number of data are 9. So we're going to use this data set again for finding the correlation. So go to the stat, go to the test, and go down CDE linear regression test. That is what we want for finding the correlation coefficient. Hit enter, and using the the list L1 and L2, same thing, but this time we're excluding 1010. And if you go down and then just hit calculate, it's going to give you all those information one more time, and as you can see that the correlation coefficient R is 0. So the answer is 0. Okay, so if you exclude that one point, then these data sets are not, this, as you can see that the correlation coefficient is 0. When if you include this 1010, the correlation coefficient was 0.9. It's a huge difference. So based on that, we have some other conclusion. One more time, is there a linear correlation between x and y when alpha is 0.01? One more time, For finding that answer, you need to find out the critical value, and for finding the critical value you have to use this table. In this case, this time the number of data is 9 because we are excluding that 1.1010. So n is 9 and alpha is 0.01, so the value of critical value is 0.798. So as you can see here, the correlation coefficient is less than 0.79. Okay, so we can use this relation here, no correlation, because the correlation coefficient is less than the critical value. Okay, the absolute value, we use the absolute value sign when the correlation coefficient is negative. So make sure that you are using the absolute value. For the positive value it doesn't matter. The only thing matters here is because the correlation coefficient is less than the critical value here 0.798, so they are not correlated. So our answer should be one of this, C or D. No, because the correlation coefficient is not in the critical region. No, because the correlation coefficient is in the critical region. So we choose no, they are not in the critical region. Okay, so look at here, just by excluding one point we concluded that hey, they are not related, correlated linearly because of this one point. And now you can see that it's not linear, it's a rectangle type, it's a square type. Okay, if you continue, what do you conclude about the possible effect from a single pair of values? Because of this one point, it's being from correlated, linearly correlated to not linearly correlated. A single pair of value does not change the conclusion. No, that's not the case. What is, whatever happened above here, the effect from a single pair of values can change the conclusion. Yes, that's the option. Yes, so we're done with this problem, and that's how we can use this calculator for this section.